Uh, okay. Good evening, everyone. Uh, Myself, Shomitra Bishwash, and I'm a teacher uh, here at Indian School of Ethical Hacking, and I mainly teach data science related topics like data analytics, machine learning, uh, a little bit of artificial intelligence, and so on. So today, in this webinar, we are going to talk about a very basic uh, topics, or we are going to talk about very basic things about data science, what it is, why is it necessary, and how it is impacting our lives uh, and industry. So from organizations to individuals to governments, everyone is talking about, everyone is excited about, and their work or their dwellings are being affected by in a good way by machine learning and data science. So without further delay, let us start the presentation. So, can I have the first slide? Okay. So this is what I'm trying to do today. Um, there's a lot of confusion these days uh, because since it is a very hot topic, data science, machine learning, data analytics, business intelligence, uh, artificial intelligence, large language models, it's very confusing for a beginner or for a student or for any layman to understand really what the thing there is and what it does, and whether it is some kind of magic or something like that. So today I'll try to demystify, I'll try to clarify some of those misconceptions. And I'm going to introduce the field of data science, uh, how it works, what kind of software means tools we are using these days, and so on. So, next one, please. Okay. So, first is what is data science? Data science is a computer science subject, as well as it is a mathematical subject, as well as it is a statistical subject. So it is not a pure uh, topic or pure subject of study, uh, like physics or chemistry or things like that. Instead, it is an interdisciplinary subject where we need the skills of multiple subjects from computer science, mathematics, statistics, uh, to solve certain classes of problems, certain types of problems. Now, along with that, we also need some domain knowledge. Means that uh, suppose we want to solve some data science problem, data science related problem in the area of retail marketing. So there the data scientist will be there, and along with that, a person from the field of retail marketing or management, that person needs to be there also. So it's not the subject for geeks or nerds or something like that. It's a collaborative way of doing things uh, with people who know mathematics, who know statistics, who know programming. And along with that, we also need people from that relevant fields. Okay. Next is importance and applications. Uh, Now, if I want to talk about importance, then uh, talk about talk about importance, then it will be very long thing, because it is so important today, because everything uh, we do it by some form of digital devices, be it laptop, uh, smartwatches, desktops, big servers, supercomputers, data centers, cloud, everything, everything that we use in one way or the other deals with data. And since data science is the science of gaining knowledge from the data, uh, gathering data, understanding data, and do something uh, very sophisticated things like prediction with that data. So it is very important. And if I want to specify some fields, it will be industries, including finance, healthcare, marketing, technology, schools, colleges, everyday uh, workings of individuals. Everybody is using data science in one way or the other, even if they don't know it. So, knowingly or unknowingly, we are using some facets of data science topics. Uh, so, it is very important. Skills required. Now, this is the thing that every student wants to know. What are the things that we need to enter into the field of data science? Uh, First of all, uh, a basic understanding of statistics is required. Without it, some topics will be very hard to grasp. A little bit mathematical knowledge is also required. High school mathematical knowledge will be good enough. Along with that, at least one programming language like C++ or Python or JavaScript, that is required. That programming knowledge or programming skill, that is also required for uh, technical purposes. Along with that, you need to have, or anyone that they want to come to this field, they need to have an inquisitive mind, analytical mind. Uh, you need to know, you need to have the passion for challenges, okay, um, and problem solving. Sometimes the data that we get is not from our field. We do not have knowledge about that data, uh, but uh, usually we talk with the respective domain experts to solve those problems. So inquisitive minds, some basic knowledge of programming, mathematics and statistics is all that you need. And along with that, you need to be hardworking, very hardworking. So it's a very labor intensive task. So you need to be hardworking. So next one, I'm going to talk a little bit about uh, data science life cycle. What do you do with the data in this field? So first thing is that data collection. We need to have data in our hand to do something with it. Now, what do we mean by data? Say, for example, I was talking about retail sector. So suppose I'm talking about a shopping mall, say uh, X. So X is a shopping mall, and it has some branches over India, sub cities. So say it has 5 or 6 branches. Now it wants to know uh, the shopping trend of its customers, or footfalls of its customer during uh, 2 to 3 p.m., means in the afternoon, every day. So for that, it needs the data. Who are coming? Uh, what is their age? What is their purpose of visiting? Means whether they are coming for uh, tea or some beverage in the food court, or they are actually buying something, or simply they are coming to hang around. So what is their purpose, what are they buying, and how much they are spending, uh, and what are the uh, repetitions of them, means once they buy something, if are they coming in the next week or next month, so are they repeat customers, so on and so forth. So for that shopping mall needs to have those data. So it's not only useful that you sell something, but along with that you need to have the data about the customers also. So I can go on and on about data collection, and probably I'm going to talk about data collection in some other webinar itself. So today I'm just going to give you an overview of the whole thing. So next go to data cleaning. And now, uh, what do we mean by data cleaning? Data is there, but we need to have it under um, enough uniform, uh, what do I say, uniform standard rather. Okay, so suppose one center or one shopping mall, one of the branches, they are storing data in some format, and others are storing data in some other format. Say the date of buying. So in one shopping mall, it is month, then day, then year, and in another shopping mall, it is first day, then month, then year. So the date of purchase is different. This format is different. Now, if we want to do anything with the data, we need to have it under an uniform uh, umbrella. It needs to be uniform. So that is known as data cleaning. So that is basically data cleaning. Data cleaning also means if there is some error in the data, or suppose someone has bought something, and for some reason, computer glitch or network glitch or something, for some technical reason, some data is absent from that purchase. Now, when it is absent from that purchase, we need to know what is the reason for that and what do we do with that data. Suppose a customer bought something, so a product has been sold and the money has been received, so only that information is available. uh, the name of the customer, age, gender, the amount spent, nothing is there. Okay, so what we are going to do about the data item? Usually we are going to just delete the data item, but it is not always the case. Okay, it's not always the case. Sometimes we replace bad data or absent data in a certain manner. So there are algorithms, there are techniques for doing that, and along with that, we need to have everything under same standard or same scale to make the analysis. So first is data cleaning, then first is data collection rather, then data cleaning, and after that uh, we go to data analysis. Now, in case of analysis, uh, what we do over here is known as exploratory data analysis. Some slides later, I'm going to talk about it in more detail. So, in data analysis, we try to understand the data. Uh, what different fields means, what are the different facets of there, and we try to do it in a visual manner also. So it's not it's very good to know that almost 60% of the customers during that 2 to 3 p.m. are females, uh, and 20% are male, 20% are teenage female and male, rest of them. Okay, so that is very good to know that these percentages. Uh, but if we visualize that using some chart, like bar chart or pie chart, then it will be readily uh, understood by our client, means the owner of the shopping mall. Okay, so doing data analysis means doing something, some statistical study, like computing the mean, computing the average, computing the standard deviation, and so on and so forth. And along with that, we also visualize the data. So that part is known as data analysis. And after we do that, we do some model building for prediction. So this part is machine learning part, model building part. Before that, after data analysis part, it is mainly known as data analytics. So the first three things, collection, cleaning, and analysis, is known as data analytics. Uh, it is also known by the uh, acronym of ETL, extract, transform, load, and along with that EDA, exploratory data analysis. But after has done, uh, that has been done, we do some model building. Model building means there are algorithms that take an input, and that input is the data that we are trying to analyze. And once we present that data to that uh, algorithm, it learns about the data. What do we mean by learning? Uh, for the time being, let's stop at that. It learns about the data, and it generates an ability to predict something about the data. Okay. So for our shopping mall example, once a person buys something, if we have a model for that shopping mall, then we are quite sure that the person is going to come back if our model says so. Okay, so if the model says that this person is going to come back, say 1 month or 2 months later or 1 week later, then we are pretty sure that the person is going to come back later. So how it is done, it sounds like magic, but it is not. But it is done. Okay, so the algorithm develops that ability. Next, we have deployment. So once we build a model, we need to do something with it. Okay, so it's a computer program, and how we are going to use it. So from the shopping mall's owner's point of view, we need to make it useful for that organization, that business owner. Okay, so for that, we create some website or embed our software into that website, in some web page, or create a web app, or create some desktop app. So that is the software development part. Once we have our model, we create a software out of it, or embed that model into some software, and that is known as deployment. Once that is done, it becomes a software or part of a bigger software, and the standard monitoring and maintenance is done. For example, I don't know if some of you have tried it or not. Uh, Today, Gemini is not working. So Gemini is a large language model for Google. It is not working. Okay, so probably something is going on over there, over Google. Some form of glitch has been found, or some something wrong with it. Okay, so they are maintaining it. So it is down for the time being. So that is known as monitoring and maintenance. It's just like maintaining a normal software. Okay, so let's talk about sources of data, data collection techniques, and challenges in data collection. Now, sources of data uh, is can be as varied as the data itself. So it is very, very difficult to give you an overview even about the sources of data. For example, if I say that I'm a person and just right now my data is being created in about say two or three websites every second. So I'm talking in a webinar and my data, my voice, my picture, uh, it is generated in this software itself, the web. I'm online in WhatsApp and my official email. So there also my data is being generated. My phones are online. So the phone companies, they are also my data is being generated. So I can talk like I can give you an example of me, but I can give you an example of everyone. Okay. And this kind of now imagine uh, every car, every bike, they are also generating data. How? Every car is now connected to some server. Okay, so that is how you are. If you are in a trouble, then you can get hold of the car mechanic so fast. Every motorcycle, I mean modern motorcycles, modern motorbikes, they are also connected. They can have internet connectivity. Smartphones, of course, they are like mini desktop or laptop computers, right? But along with that, smart watches, smart TVs, smart refrigerators, all these are sources of data. Along with that, almost everyone uh, these days are online, means they are online in some social media applications like WhatsApp or Facebook or X or something, some other uh, Instagram, something like that. All those websites, all those servers, all those uh, computers, they generate data in a blinding speed. Okay. So if I say that uh, every day the kind of data that is being generated is more than what was generated from the beginning of time of human race up to the uh, digital age. Would you believe it? But it is true. So all the literature, all the images, all the um, songs and lyrics and everything that human being has created, if you take all those things together, every day we have more data than that, new data than that. So sources of data can be any digital device that has the ability to connect to some network or internet. So everything, each and everything. Now data collection techniques. So these are challenges. And data collection techniques are itself challenges because data are coming from various sources in various formats, and we need to make them uniform so that analysis can be performed. And data collection, under data collection techniques, we have surveys and interviews. All of us get some surveys once in a while in YouTube, right? And they say, would you like to take this survey? If you say yes, then there are some questionnaire, and one after the other these questions come, and you give some answer, and that is one way of taking data from the users. Uh, there are interviews, like if I go to some educational website, they take virtual interviews, like what is your passion, what you're going to do, what do you do right now, and so on and so forth. What is your interest, and so on and so forth. So that is one way of another way of collecting data. Other ways are automated data collection methods, like just now that I have said, the data that is being generated by these social media servers. So that are some kind of automated thing, right? So I'm talking to you over WhatsApp, and as a side effect, the servers in the WhatsApp organization that is getting the data. So our conversational data, maybe it is encrypted, but it is going there. Now if I order something online, so there the data is there. Okay. So I want to eat that food, I have ordered it this time and this time, so their server will store that data. If I go somewhere, say taking an Uber, then that company, Uber or something like that, they are also going to have our data, from where I took the cab, when was it, how much did I pay, did I choose for AC or non-AC cab, and so on and so forth. So all those data will be there. So these datas that are being gathered, they need to be collected and make uniform so that it can be analyzed. So those are the challenges that we face. So data needs to be in good quality, it needs to be uniform, and along with that we also need to make sure that the privacy of the owner of the data has been maintained, and proper access restrictions are there so that unauthorized access cannot be made. So certainly, we a big field of data, application of data analysis and data science is healthcare. Now, in healthcare, the data that is there is the patient data, right? And that is very, very confidential data. It is sensitive as well as confidential as well as private. So some data analyst or some data scientist may work with that data, and they do, because it is a very, very important field where data science is used. But that data should not and never must not fall into the hands of people who are not authorized of accessing that data. So data privacy and data security, it is applicable in data science, data collection, data analysis, whatever you may say, like every other field of study. Okay. So next one, uh, data cleaning. Let's talk a little bit more about data cleaning. First is why we need to clean the data. Now, let me give you an abstract example. Suppose you want to buy some apartment in some city, okay, and you want to compare prices of different apartments in different areas in that city. Now, one of the things that influence the prices of a house is the area of the apartment, right? Now you say that you go some website and you view some apartments along with their uh, prices, and you saw there that their area is in square foot. Now we go some other website and see some other apartments, and over there the area is in square meters. Now tell me how you are going to compare the prices of two apartments or two or more apartments if one of them is in square meter and one of them is square foot. You cannot, right? So we need to convert those two parameters into one, like either convert square foot into square meter or vice versa. We cannot keep them in different unit measures. So if we do that, then the data analysis will be wrong. Okay. Now suppose uh, in the same fashion, you are trying to find out, you are hunting for you are looking to buy a new apartment, and you are looking for apartment that has garage spaces. Okay. Now you see, most of the time the apartments that you see do not have any garages, or in case of garages it is written not available or unknown. Now, what is the meaning of that? It is unknown because the people who took the survey, they do not know about the garage situation, or it is not available, means the garage is not there. You cannot say that, right? You cannot decide. So you need to come to a conclusion. What is the meaning of that? Not available, unknown. What is the meaning of that? So that is also data cleaning. Sometimes you'll see that maybe there is say address of an house or number of a house. Now in number of a house there's written blank, nothing is written there. So house number cannot be blank, right? It cannot be blank. So these, if we do not do this, then the data that we try to analyze will not be meaningful to the algorithms, will not be meaningful to us, will not be meaningful to any software that we are going to use, any programming language that we are going to use. And no matter how sophisticated algorithm that we use, no matter how intelligent we are, if the data is wrong, then the result will also be wrong. Analytical result, the models will all be below standard. Okay. So that is the importance. Techniques, I have already talked about that: removing duplicates, handling missing values, outlier detection. Now let me talk about a little bit about outlier detection. Suppose uh, I am uh, analyzing the credit card usage behavior of um, some people during holidays, during festive times. Now there will be some people who are going to buy astronomical things. Okay, we are going to spend astronomical or very very large sum of money through their credit card during that same period. But otherwise, every other people or all of them are going to use some moderate, uh, are going to spend some moderate amount, right? So those, barring those one or two people who are spending a lot during the holidays, others form a group, and that particular maybe say handful of people who are far away or far greater in terms of spending than the rest of the batch, they are outliers. When we are dealing with when we are analyzing a data set or analyzing data, we need to have some policy about outlier. I said policy because it must be a policy. It cannot be uniform. It has to change from data set to data set. Uh, why I say that, I'll explain later. Okay. Now, what are the tools that we use? So these are different tools that we use. Tools means softwares, or rather, these are like pandas. Pandas are a library written in Python and used in Python programming. And Power BI is a software, a free software from Microsoft. So the first one you need to program, the second one you need to point and click. So there are different. These are just a few example, a couple of examples of tools. There are many other tools that are used in data science or data for data cleaning. Okay. So let's talk about exploratory data analysis a little bit more. So exploratory data analysis, what it is exactly what it says. Exploratory, it explores the data. So during this phase, we explore the data. How many columns it has, how many parameters it has, how many records are there, I mean how many data points are there. Uh, if the parameters are all in same range, means we need to do some statistical analysis for that. We need to compute some statistical measures like mean, standard deviation, skewness, kurtosis, and things like that. And along with that, we also visualize. Now, I have already talked about visualization before this slide. Visualization helps us understand those statistical results more clearly, more easily, and even sometimes they reveal a certain aspect or certain criteria that was not understood by the statistical analysis techniques. So, if if I take a visualization webinar someday, I'll talk about it more in more detail. What are the tools that we use? So these are all names of libraries that we use: Matplotlib, Seaborn, Plotly. So these are all uh, Python programming language libraries written in Python that are used to create great visualizations. So apart from these, there are some point and click tools like Power BI, Tableau, uh, other programming languages like R, JavaScript. They have their own visualization library. So it's a completely uh, self-sufficient or completely complete topic in itself. It's a separate topic in itself, visualization. And usually organizations have visualization experts who only deal with visualizing the data. Okay, so let's move on. Then we come to model building. So after that part was data analytics part. So data cleaning, data gathering, data cleaning, exploratory data analysis, and data visualization. The outcome of of that step, EDA, is a presentation, just like the presentation that I'm giving you right now. A presentation like that. Okay. So it usually tells us or tell the client uh, what has been found about the data, uh, what are the analytical results, how different charts are uh, revealing some truth or some knowledge about the data, and so on and so forth. Once that is done, we are into model building. Model building means, as I have said already, we use some algorithms, and those algorithms learns about the data and generates the ability to predict something about the data. Now, there are different types of algorithms, and accordingly, there are different types of machine learning techniques. One is called supervised learning, another is unsupervised learning, another is reinforcement learning. Now, in supervised learning, what we do, we uh, use data that is labeled. Means, suppose uh, uh, I am analyzing, I'm trying to build a model for, say, some food. Okay. And I want to take the, I want to predict how that food or food item is going to fare in the market. Is it going to be a hit? Is it going to be something that is going to go after 1 month or so? I want to have a prediction about that. And for that, the data that I have will contain the different parameters about the food item, like how it tastes, how long it usually takes to eat that whole thing, and how uh, and what the people are saying about the food item. Okay. For example, a new flavor of ice cream. So, is it the amount of ice cream that is being given? Is it very small, or is it very large? People are getting bored eating it, or it is very small. It is once we are once we have eaten it, it is gone before we know how the taste is. So that is supervised learning when the data has some result associated with it. It is known as supervised learning. So along with the food item, we have the reaction of the customers, and from that, the algorithm is going to give us some prediction about that food item, that it is going to be a hit, or these things need to be changed so that it can be a hit in the market, and so on. Now, in case of unsupervised learning, we do not have any idea whatsoever about the outcome. So suppose one example of that will be, a popular example will be customer segmentation. Okay. Again, that shopping mall that I was talking about, that shopping mall wants to know what are the demographics of its customer, what are the age group of its customers. So the customers will be uh, grouped into different uh, classes. Okay. Say according to their age. Say, and they'll see that starting from teenagers, then young people, then middle-aged people, up to old people. All of them are coming to their shopping malls, but not children. So they need to change some policy. Uh, Maybe they need to change some decor of their shopping malls so that children can also visit along with their mom and dad. So that is unsupervised learning. So that's a different kind of machine learning. Different algorithms are used over there. Now, in case of reinforcement learning, it is a reward and action-based learning techniques. Suppose a robot uh, is uh, learning to walk. Now, if it can learn, if it can walk up to a certain distance without bumping into anything, then we are going to give it some reward, okay, positive reward. And if it bumps into something, we are going to give it some negative reward, okay, some number, okay, and that is going to give it the reinforcement or the boost of learning the proper thing. So it is going to learn that it is not good to bump into things when walking, and it is good that you do not bump into things when walking. Okay. So walking is a process that should be non-eventful. Means you do not bump into something, you do not have an accident during walking. So that is the way of learning in case of reinforcement learning. It is uh, kind of supervised learning because there is some reward or negative reward or positive reward associated with some action, but it is not completely supervised learning because not every action has some positive reward. Take an example of the robot again. So if it can go from point A to point B without bumping into anything, it is going to give it is going to get some positive reward, but in each step of the way it is not going to take some not going to have that reward. Okay, so when it is taking a step, if there is if it is bumping into something, it is going to get negative reward, or if it falls down, then it is going to get a negative reward. But if it works properly, then it is not going to get a positive result or positive reward until it reaches its goal. So it is not truly supervised learning, uh, but a different form of learning, semi-supervised learning or reinforcement learning. Next is model. So again, these are scikit-learn, TensorFlow, Keras. So these are all libraries written in Python programming language that we use every day. There are other programming languages, as I have said already said, like like R, JavaScript, C++, Java, that can be used to create machine learning models. But they have different libraries also. So vast array of softwares are available to create different models for us. Next is deployment. Now this deployment means once we have the model built and it is working properly, it is giving us generate good results, it is going to be deployed in one form or the other. Now those who are using Android phones, they have something called Hello Google or Hello Siri if you have Amazon Siri, Apple Siri, I'm sorry, Amazon Alexa is there. So those are examples of deployed machine learning models. So in case of that small widget where you say, hello Google, call this one or this person, that is also learning, that is also using some machine learning algorithm to uh, locate and call whomever you are trying to call. And even before that, it is understanding your voice. And so a machine learning application is running. So machine learning application means it can be a software, a small widget like in your phone, smartphone. It can be something that is part of a bigger system like Amazon Alexa. Now, in case of Amazon Alexa, you can have a separate device where you can say communicate with it, but you can also have Alexa in Amazon app also. So if you open your Amazon app and say, okay, I want to buy this product, it is going to give you, it is going to show you those products. You don't have to write it by your finger or something like that. So deployment means that once we have created a model, it is working fine, it is working properly, then we are going to deploy, we are going to use that thing inside a software, inside a hardware, or by all by itself, like creating a small widget and uh, becoming a part of a part of it as Android operating system. Now, what are the things that we use for these purposes? We use APIs, microservices, containers like Dockers, Kubernetes, Flask, and so on and so forth. So these are a little bit advanced topic that don't want to go any further in this webinar today. Now, next one is monitoring and maintenance. So this is completely this has nothing to do with machine learning or data science. It is true for every software that we create. Every software that we create has to be monitored, and if there are some problem with it, it is not working properly, it is not giving us good result or expected result, then we need to fix those errors, and we also need to improve continuously. Okay, so we need to have different versions of it, just like the operating system gives us different versions, improved versions, one after the other. We need to have it continuously improved. Okay, so it is normal. Now, what are the tools that we use? Again and again, the tools are coming because everyone wants to know how and what are the tools or what are the software that needs to be known for this data science technique. And to be honest, this slide is uh, is not going to give you even the slightest hint of the amount or the vastness of softwares that are used in this field. Just to give you an idea, just the data gathering and cleaning part, and that is known as the data engineering part. It has more than, say, 20 to 25 softwares that are used today. It has more, but uh, popular softwares at that. Okay. Big data technologies, Hadoop, Spark, there are others. Okay. Programming languages, only three are written: Python, R, and SQL. Uh, there are many more. Cloud platforms. Okay, so these three entities are big players: AWS, Azure, Google Cloud. There are some others like Salesforce and so on. Uh, Cisco is coming in a very big way. So for the time being, Amazon, Microsoft, and Google, they are the three big players in cloud, and also they are implementing machine learning in a very big way in their cloud platforms. Okay. So, okay, so that concludes my presentation for today. If anyone has any questions, I'm ready to give answers. I'm ready for that. Are there any uh, listeners? I guess not. So, that concludes my presentation today. Okay, and see you next time. Thank you.